scientists, policymakers, and practitioners who came here for discussing the sustainable future of Indian soils. Thank you very much for joining for this noble cause here. Now I will be explaining, all the speakers till now spoke about non-chemical agriculture and everything. Yes, we have used much and much fertilizers, injudicious and imbalanced fertilization. All the problem for all these thing is the imbalance of the chemicals and all these things. Let us see how we can come out of those problems by using the ICTs, information communication technology, also into agriculture. This is soil resource inventory using GIS and for sustainable soil health management. Yes. So what is this? Soil. Soil is, in simple terms, in very simple terms, if you want to say, it is the source of infinite life. Every life comes from the soil. So it has to pump the nutrients and water continuously, minute after minute, day after day, season after season, year after year, and generation after generations. The soil has to pump the nutrients and water for the successful growth of the plants. Otherwise, no life, no food, nothing will be there. The entire world will going to be extinct. So this, in very simple terms, if I want to say, it is the source of infinite life, and this soil must be protected for generations. So just as our heart pumps the blood, the soil has to pump the nutrients and water. But what is happening? See, the pressure is building up as we are speaking since morning. So the population is increasing. So it is this one. This is today morning figure, and it is going to be 1690 million by 2025. Likewise, for the food grain production is also required. So what is to be done for this? So for every 2 seconds in our country, we are adding 1 person. Balancing the births and deaths, we are adding, for every 2 seconds, we are adding 1 person. So for this increasing population, we have to feed everybody. So what is this figure? This is less than 1 kg to 141 kg per hectare. Actually, before during the early years of independence, we used to apply only 0.45 kg of fertilizer per hectare on all India average basis. Only 0.45 kg. But what is the case now? It is 141 kg. This is all India average basis. In states like Punjab, Haryana, Andhra Pradesh, we are adding more than 200 kg of fertilizer per hectare. This is the alarming situation. So this is, what is this figure? 0.7 lakh metric tons to 220. We have started with a modest beginning of 0.7 lakh metric tons of fertilizer production with a plant at Ranipet in Tamil Nadu. But now our production level has been increased to 277 lakh metric tons. This is one more important figure. See, what is this? 1 lakh crores. This is a very astonishing figure. What is this? Anybody can guess? This is the subsidy the government of India is giving on fertilizer. This is the maximum subsidy that the government of India is giving on for anything in our country. So this much of subsidy is being given. So based on this, we have increased the fertilizers, we have used the fertilizer usage, and so in the early years, during the early grain revolution years, when high yielding varieties were introduced, fertilizer responsive varieties were introduced, the fertilizer response is like this, 13.4, and it has gone down to 3.7 in the 2009, and it will be much lesser today. So I'm giving some facts what is happening to our soil. Here, see, as our Deepak sir has already given, this is the scenario. What is happening over the years? Over 100, maybe 2020, some micronutrients are also coming. The question mark will be there in for future. So with all these things, the Indian agriculture came to at crossroads. So what are the reasons for decrease in productivity? High nutrient turnover in soil plant system along with low and imbalanced fertilizers. We are always mining the nutrients from the soil, we are producing the crop, and we are transporting it away from the place where it has been produced, and so the nutrients are being mined. Emergence Emerging deficiencies of micro and secondary nutrients. I have already explained. Soil degradation because of your intensive cultivation, soil and other factors due to climate change and all, the soil is being degraded. Skewed nutrient demand and supply. So the supply, there is a difference between demand and supply. Consequently, all these factors are making the soil quality deterioration, and fertilizer use efficiency is also being reduced. So what is to be done to safeguard from this is we have to use the ICTs also, information communication technology also into our agriculture. Here comes the soil. We must digitize. So our Prime Minister has also given importance for digitizing the soils and digitization of the things, and soil digitization is also needed here. So soil resource inventory we must create for all the soils of the country. Then we will be able to know the status of our soils. Only when we know the status of our soils, then only we will be able to make some decisions. We will be able to make rectifications. So first we must have the capacity. What is the capacity of the soil? Then only we will be able to make some recommendations. For that only soil resource inventory is needed. So what is the goal of this? What is the sustainable soil health management is our goal. For that, what are the objectives that we must keep is to first collect the database of the soils. How it will be done? It will be done with the help of GPS. Nowadays we will be having the GPS in all the smartphones, and also we can collect while collecting the soil sample, we have to go with the GPS only, so that we will have the exact location of the soil. Next, it has to be analyzed for different nutrients. All these days we used to analyze the soil only for chemical parameters, but the microbial parameters are also important. Physical, chemical, physicochemical and microbial properties must be studied. And then we can prepare the nutrient status maps, and then we can prepare the fertilizer recommendation maps also for which particular soil request what is the quantity of fertilizer for growing particular crop, and then we can go for the customized fertilizer formulations also. How the methodology is, I have already explained. First we will be collecting the samples with the help of GPS, then we will be analyzing with in the laboratory, then we will be preparing the nutrient maps, and soil quality index will be calculated. Then basing on the FAO land evaluation pattern, we will be able to suggest whether the particular soil is suitable for growing particular crop. Say for example, one soil is suitable for paddy and may not be suitable for wheat. If we grow the wheat in that which is not suitable for that soil, we are not going to get any yields. When once we know that the soil is suitable, then we must know what is the quantity of fertilizer to be applied. That we can know from the soil test crop response equations. And then we can go for customized fertilizer formulations also. That is for the crop, for the particular crop growth stage, based on how much fertilizer is to be applied, and top dressing, first top dressing, how much fertilizer is to be applied, and the second top dressing, how much fertilizer is to be applied. We all can be customized for particular crop, for particular crop growth stage, for particular field we can give. And these are some of the photographs. See soil site suitability. See for example how the soil difference. So this is for rice crop, paddy crop we take. See here, these are the different parameters based on soil drainage, soil texture, soil depth, soil erosion and soil slope. Based on these parameters we will be able to analyze whether the soil is suitable or not for particular crop growth. So if clay, silty clay, clay loam, silty clay loam and sandy clay loams are highly suitable for paddy cultivation, whereas highly drained sandy soil loams and sandy soils, loamy sands are not suitable. So in the same manner, soil texture, soil drainage, imperfectly drained soils are highly suitable for paddy, whereas well drained soils are not suitable. Say for you will be able to understand. This is one of the example. Let me skip. See, this is another crop. This is Bengal gram crop. For this, the opposite of paddy crop requirements are required here. So if you grow the crops, paddy crop which is suitable for Bengal gram, it is a failure. So then we have to create the nutrient maps like this. This is for different nutrients we can create. This is nitrogen map, which shows most of the area is having low nitrogen and a part of it is having only 4.43%. This is one of the study areas. This is phosphorus map, and this is potassium map. If all these maps for individual nutrient it is there, we cannot make recommendations. Then we have to use we have to overlay one over the other so that we will be able to make some meaningful recommendations. Say we are here, this is K map, phosphorus map and nitrogen map. If we can overlap on each other, we will be able to get the zones different. What is the fertility status of different zone? What are the fertilizers to be required to fertilizer, quantity of fertilizer required? We can make recommendations. This is L means this is low for N, P and K. First N and second one is P, for third one is for potassium. Like that we can make recommendations. This is in the different zones. What is the percentage of area is lying in different fertility zones? We will be able to know that. So based on that, soil fertility, generally 240 kg per hectare of nitrogen is required for paddy cultivation in this study area. But based on the soil fertility, if you can see here, only very less quantity of fertilizer is sufficient to produce the optimum quantity. So this is in the same manner. I have given spatial fertilizer recommendation maps can be given. So what is the in which area request different quantities of fertilizers can be explained here. So this economics, anyway, I am skipping it here because of paucity of time. Say this for one particular division. So each division, this is a revenue division, means in one district 3 to 4 revenue divisions will be there. For one revenue division, for one paddy crop, if we go for with the soil resource inventory, if we go for soil test crop response equations and make fertilizer recommendations, we are going to save 5 to 15.2 lakh rupees in one crop, for one crop in one division. For likewise, if for the entire country, if we can make a large amount of money will be saved. Not only the money, the most important point, since morning we are discussing the soil health, soil fertility will be maintained. So based on this soil health cards we have prepared, and based on that fertilizer recommendations for different crops, we can, what is the, if the soil fertility status is low, we have to go for this much. If it is medium, we have to apply this much. If it is high soil fertility is high, we have to apply only lesser quantity. For different seasons, for different crops also, we can make recommendations based on this. So our Honorable CM has distributed for his constituency, Kuppam is his constituency. We have distributed soil health cards for all the farmers in this constituency, and the fertilizers are being applied only based on soil fertility in this constituency. So output is in the form of that soil health cards can be given, and that will be used for the comprehensive agriculture action plan. Yes, madam, thank you. But one important thing to conclude, that as madam was telling, that the seeds have been kept 1400 kilometers deep of North Pole, but our soils we cannot keep anywhere. So the soils have to be kept at those places, and we have to protect them, we have to manage them, we have to produce crops from these soils continuously, generations after generation. So let us join hands to protect the soil for future generations. Thank you.
Done to that. And second is to Dr. Reddy. You suggested that using GIS to analyze soil, but as you rightly pointed out, your recommendation is basically, and Dr. Sabya mentioned, is also a chemical recommendation. Is that actually a solution to the problem, or we are repeating the problem in a different context? There is no other solution to soil problem than applying more urea and other stuff. And talking about this soil health cards, the question about your presentation, I'm not sure what kind of prices you use when you compare organic versus chemical. If you are using, let's say, market prices, there will be bias on one side. If you are using imputed, let's say, shadow prices, there will be a bias on the other side. So the price aspect is not very clear. I completely agree with your observation on soil health card. Dr. Sen mentioned is the program was taken off. In our area, I live in Madhya Pradesh. The experience is very, very miserable because all kinds of analysis is done, results are unclear. Last question is to Deepakji. You live in Madhya Pradesh, I also live in Madhya Pradesh. And I asked you in the lift, what has been your experience of advising Madhya Pradesh government, which is going in a heavy chemical and green revolution path, from being a balanced state, it's actually going into a green revolution path. Thank you.
So, I'm really sorry, we have to touch on the question because we actually have passed
regarding, you asked for, yes, immediately if we go for completely natural farming, zero budget natural farming, as I have already told you, for every 2 seconds we are adding 1% to our country. Immediately if you go, it may not be a possibility. So phase wise, initially, first start reducing the imbalances. First go for the integration. Then slowly we can go for the. Sir, for your question, for different crops, yes, we can go for. As an example only, for clarity of understanding, I have taken one crop. For any number of crops, we can make recommendation.
I am asking like the area specific.
Yes. Area specific, yes, otherwise we can put it in other way that this area is whether suitable or not. If it is not suitable, we can recommend, that is more than sufficient. All the other crops are suitable, they will grow. If whatever the crop that the farmer is going to interested to grow, if he can ask, we can say yes, this is suitable. If it is not suitable, we can say it is not suitable. I think that is okay. So for your 80s itself micronutrient recommendations, I don't think. In 80s itself, they started giving micronutrient recommendations.
I had about records.
Okay, maybe yes. If it is in that way also, high means yes. Some nutrients they stay in the soil. Say for example phosphorus, that will be fixed in the soil. If you won't apply even for 3-4 seasons, there will not be any problem. Say, let's take for the other example of nitrogen. If you apply the nitrogen, it will be used by the plant in a day, 2 or 3 days. All the other nitrogen will be lost either as devolatilization or leaching or along with the running water it will be moving. So that may be the reason for your question. Sir, for regarding the soil health cards for rain-fed areas, yes, even for rain-fed areas also the recommendations are there for both irrigated and rain-fed agriculture for both Rabi and Kharif seasons. For fertilizer recommendations are there. Based on that only we can make recommendations.
Okay, sir. You recommend a nitrogen for a rain-fed condition. Nitrogen is,
Yes.
in the solid form. That has to be diluted with water.
Yes.
And that has to be depending on the rain.
No, anyway,
What do you do with that?
anyway we will be applying only when the rain comes. You are not applying just because.
So the fertilizer will be used and the rainwater will be used to dilute the fertilizer, not to enter into the soil.
No, that depends. Anyway, even if we go for with soil test or without soil test also, if you are applying the fertilizer means that is only when there is a moisture. That is the case.